etc. So we are gonna discuss, we are gonna see some more examples like I'm typing here. If you can see this, okay. The question is calculate modular ratio of concrete, of grade of concrete, grade of concrete M25. This is the question. And how we are going to solve this? First of all, we should know what is the formula for M20, what is the formula for modular ratio. Okay, I'm writing here. So M is equal to what? M is equal to 280 by 3, okay, sigma EBC. This is the formula for modular ratio. And for sigma CBC, what is the formula? There is a direct value for various grades of concrete. So for sigma CBC for M25 grade of concrete, the value is equal to 8.5 for M25. Okay. Now coming to the M value, M is equal to 280 by 3 into 8.5. What is the value that we can obtain? So wait a second. 280 by 3 sigma CBC. So the value is 10.98. So this is the answer for modular ratio for M25 grade of concrete. Okay. Now coming to and so okay. okay, assumptions in singly reinforced structure. Plane section remains plane before and after bending. I have explained in previous class what is the meaning of plane section remains plane before and after bending. And next point, all tensile stresses are taken up by steel reinforcement and none by concrete, because concrete only takes compressive stresses. Young's modulus of elasticity for concrete is assumed as constant, that is 5000 root FCK. Modular ratio has the value of 280 by 3 sigma CBC. There is a perfect adhesion between steel and concrete, and no slip takes place between steel and concrete. So if there is a slip takes place between steel and concrete, what happens? Obviously, then it will be subjected to failure. And coming to analysis of singly reinforced section, so there is effective cover, there is a term also known as clear cover, which is nothing but the nominal cover. And I have mentioned in a detailed manner what nominal cover means and what is the minimum nominal cover for various structures like beam, slab and column and footing, and what are the minimum nominal covers in various exposure conditions. Okay, likewise I have explained to you, and what is the additional cover thickness that should be provided when other than beams are considered. So those are all the points that I have covered in previous class. Now coming to the equivalent area of concrete. If you see the original cross section of the beam here, there is a tensile reinforcement provided in the tension zone. So in the next diagram, in the second diagram, you can observe it. You can observe the equivalent area of this beam, in which the steel reinforcement is not taken. Why? Because we have to analyze it. We have to calculate the compressive and tensile forces. If steel is removed, what is the area that will be occupied by concrete in that portion? So that is the thing we have to find out. So that's why we have removed here steel, and we have found out the find out the equivalent area of concrete using the formula AC is equal to MAST. But in terms of Young's modulus, ES will be, that means steel's Young's modulus will be in numerator, but in terms of area, concrete's area will be in numerator. That means M is equal to AC by AST. M is equal to area of concrete by modular ratio is equal to area of concrete by area of steel. So that's why here AC, that means equivalent area of concrete. If you have to find out, then M is equal to AST is the formula. So here the middle line, that is the imaginary line, that red line represents the neutral axis. So the depth of neutral axis from the topmost fiber of the concrete to the neutral axis is denoted by XA, and the effective depth I already discussed in the previous class what effective depth means. From overall depth we have to deduct the effective cover from the bottommost fiber of the concrete, then we can get effective depth. Okay, and I also discussed another term called lever arm. What lever arm means in previous class. So here likewise the strain diagram will come. Strain diagram here in neutral axis, both compression and tension will be 0. That means no strain and no stress exists in the neutral axis. In topmost fiber of the concrete, compressive strain will be maximum, and in bottommost fiber of the concrete, tensile strain will be maximum. And coming to stress diagram, in stress diagram what happens means the tensile stresses will be carried out by steel only. That's why with the center of gravity, in the line of center of gravity only, we can observe the maximum tensile stresses. We can observe the maximum tensile stresses. Okay, not in the bottommost fiber of the concrete. In the bottommost fiber of the concrete, what happens? Maximum strain will come, but in the bottommost fiber of the concrete, it has no guarantee that the stress will also be maximum. So in the line of center of gravity of the steel reinforcement, there the stress will be maximum. As far as the outermost topmost fiber of the concrete, that means CA, their stress will be maximum. It lies in the topmost fiber of the concrete only, because the above the neutral axis there is a compression zone, and below the neutral axis that is a tensile zone. And coming to the actual depth of neutral axis, that is XA. What is the depth of neutral axis? It is a depth of that means actual depth of neutral axis means the depth of neutral axis which divides the overall section in compression and tension. That means what portion the tension is, what portion the following portion is subjected to tension, and what other is subjected to the compression. So that depth indicates the actual depth of neutral axis. It is the depth that does overall failure is due to the concrete or steel or both. Okay, the overall failure that is coming, whether it is from concrete or whether it is coming from steel or whether it is coming from both concrete and steel. So this will be told by what factor? Actual depth of neutral axis. It is the depth of neutral axis which may be calculated by equating the moment of compression and tension. So by equating the moment of area of compression and moment of area of tension, the depth of neutral axis can be calculated. So here derivation is given, moment of area compression. So the area moment of area formula is area into its center of gravity actually. So above, if we see the above portion, that lies above neutral axis, so it is a rectangle. So the area of rectangle formula is B into D. So here D is not overall depth, not effective depth, but the D only half of the what effective depth. Not only not necessary it is the half of the effective depth, but it is indicated as XA. So B into XA. Until the above portion, the area is B into XA, and it is multiplied by center of gravity. Center of gravity lies exactly in the exactly half of the depth of the neutral axis. So B into XA into XA by 2, and it should be equated to what? Moment of area of tension. So moment of area of tension. So first of all, in this portion, in terms of concrete, if you want to find out the area of steel, then what I said, okay, then what I said, then AC is equal to what happens? MAST, and AST will be equal to AC by M, like that. So here we want to find out the AC only, because in above the above lying portion we have calculated in concrete terms only. So below the neutral axis also we have to calculate and we have to formulate in concrete terms only. So that's why we have taken in terms of concrete. So in terms of concrete, EAC becomes MAST, and it is multiplied by the depth. What it becomes? D minus XA. That means in total effective depth, XA portion will be removed, then it gives us the remaining portion of the effective depth, that is D minus XA. So on overall basis, if we simplify the equation, CA by XA is equal to T by M. Here T means sigma ST actually, stress, tensile stress actually. M means modular ratio. D means effective depth. XM is actual depth of neutral axis. I hope you understand. Next, critical depth of neutral axis. Okay, what is critical depth of neutral axis? When steel and concrete fail simultaneously, at that time overall structure fails simultaneously. Okay, na? So for the structure not to be failed under the load, then it should be what? It should not fail simultaneously. Either the steel should fail initially or the concrete should fail. If the concrete and the steel fails simultaneously, then overall structure will be occur due to failure. So this is the depth in which the variation cannot exist. Therefore, it is also called as ideal depth of neutral axis also. So critical depth of neutral axis also what? Ideal depth of neutral axis. So here variation cannot be existing. So that's why. But in actual depth of neutral axis, variation can be existed, but in critical depth of neutral axis variation cannot be seen. So how we are going to calculate this critical depth of neutral axis means, here derivation is given. See, first of all, using this stress diagram we will adopt the properties of similar triangles. So here in topmost fiber of the concrete, maximum stress is sigma CBC, and the depth is XC, that means critical depth of neutral axis. Okay, na? Leave this section whatever it might be, whether it might be under reinforced, whether it might be over reinforced, whether it might be balanced section, whatever it might be, but the we know the depth of critical axis or the depth of ideal neutral axis. Okay, so then it is XC. So here only what happens, the the neutral axis lies actually. So this is the balanced sections balanced sections overview actually. In balanced section what happens means, actual depth of neutral axis will be equal to critical depth of neutral axis. So that's why you are seeing here a neutral axis lying on the line where critical depth of neutral axis lies. So the maximum tensile stresses, here you can see the sigma ST by M, it becomes sigma ST by M. Here it is the maximum tensile stresses, tensile stress. Okay, and the remaining portion from the, excluding the XC, it gives us the depth of the tensile zone, the depth of tensile zone. Okay, likewise, we have known the XC, the depth of critical neutral axis, and the if depth of critical neutral axis is excluded, the depth of the remaining depth. Okay, all these factors have been known to us, then we can adopt the single similar triangles property. From the properties of similar triangles, what happens? Horizontal length by vertical length is equal to horizontal length by vertical length. Likewise, we can write this formula, and from this formula this equation will be coming from the next step. Okay, if you send the exceed to the right side, it will go in numerator, and the sigma cbc will go in denominator, and this m will be multiplied to this denominator, and remaining sigma st will be going into the denominator, and this d minus xc, when it is cross multiplied, it will go into the numerator. So that's how this equation comes: xc by m sigma cbc is equal to d minus xc by sigma st. So from that equation, sigma st by m sigma cbc is equal to d minus xc by xc. Why did we write that? Why did we write like this? Because we are taking the stresses terms in one hand side, and we are taking the depths in right hand side. So from this equation comes sigma st by m sigma cbc is equal to, if we make the xc as common, then d by xc minus 1 will be coming. So from this, xc will be is equal to m sigma cbc by m sigma cbc plus sigma st into d, which is written in red color. So if we consider the m sigma cbc by m sigma cbc plus sigma st as k, okay na, this all term, that is m sigma cbc by m sigma cbc plus sigma st ని ఒకవేళ k అనుకుంటే ఓవరాల్ గా ఏమవుతుంది, x is equal to k into d అవుతుంది, and critical depth depends upon d and sigma st only. దీని ద్వారా మనకి ఏమర్థమైంది, ఈ ఈక్వేషన్ ద్వారా క్రిటికల్ డెప్త్ అనేది d పైన, అంటే ఎఫెక్టివ్ డెప్త్ పైన, అండ్ ఓకే స్ట్రెసెస్ ఇన్ స్టీల్ ఇన్ టెన్షన్ లో పైన డిపెండ్ అయ్యి ఉంటుంది. సో క్రిటికల్ డెప్త్ ఆఫ్ న్యూట్రల్ యాక్సిస్ మాటికంటే మనము సిగ్మా సిబిసి తెలుసుకొని దాని తర్వాత మాడ్యులర్ రేషియో క్యాలిక్యులేట్ చేసి అదంతా ప్రతిసారి అలా చేయలేము కదా. సో కొన్ని స్టాండర్డ్స్ ఇచ్చారు IS 456 ప్రకారంగా కొన్ని స్టాండర్డ్స్ ఉన్నాయి. సో అదేంటంటే గ్రేడ్ ఆఫ్ స్టీల్ ప్రకారంగా కే వాల్యూస్ అనేది ఇవ్వడం జరిగింది. సో ప్రతిసారి మనం ఈ ఫామ్లో x ఈజ్ ఈక్వల్ టు m సిగ్మా సిబిసి బై m సిగ్మా సిబిసి ప్లస్ సిగ్మా ఎస్టీ అని ఇంత వేయకుండా డైరెక్ట్గా కే అని మనం వేసేసి దాని తర్వాత కే వాల్యూ సర్టన్ వాల్యూ ఇచ్చుంటాడు, 0.40 ఫర్ FU 250 అండ్ 0.289 ఫర్ FU 415 అండ్ 0.2535 ఫర్ FU 500. Okay, these are the values of K. This is how we are going to calculate the critical depth of neutral axis. And coming to the comparison between the actual neutral axis and critical neutral axis. So based on the critical neutral axis and actual neutral axis comparison, there are three types of reinforced sections, that is under reinforced, balanced and over reinforced sections. So in under reinforced section, actual neutral axis will lie above the critical depth of neutral axis. That means it will be less than the critical depth of neutral axis. That means it would not exceed, the actual depth will not exceed the critical depth of neutral axis. And in balanced section, the neutral axis lies on the same line where critical depth of neutral axis lies. And in over reinforced section, that means reinforcement became over. So hence the actual depth of neutral axis goes below the critical depth of neutral axis. That means it exceeds the critical depth of neutral axis. So now we are going to see which kind of section is economical for us, which kind of section is more, that means more safe for us. So we are going to discuss in the upcoming slides. So before that you have to see what is the bending moment and what is the moment of resistance. You all know what is the bending moment. You have been studying since second year where bending moment you have come across bending moment in strength of materials also. So bending moment, it depends upon the intensity of load, okay, which may be equal to the moment of resistance or may not be equal sometimes. Moment of resistance, not always called as a moment, bending moment. Actually bending moment is also the moment of resistance, but it depends upon the intensity of load. That is the main point here. And the moment of resistance means the maximum capacity of the section. Okay, now the maximum moment moment of resistance is also known as the moment carrying capacity. That means how, to what extent the moment can be carried out by that section will be determined by the factor known as moment of resistance. You can understand. So here also the given the it carries the bending moment at which either the one material fails or both the materials fail. Okay, in under reinforced section, as I told you, uh, these green lines indicate, this green line, imaginary line indicates the depth of the actual depth of neutral axis, and these black lines indicate the critical depth of neutral axis. So hence we can see that XA is less than XC. That means actual depth of neutral axis is less than critical neutral axis. That means it is not exceeding the critical neutral axis. Once it will exceed the critical neutral axis, then it will become dangerous. Then it will become what? Then it should be redesigned actually, or the doubly reinforced beam should be given. Okay. Though, so the XA is less than XC. Okay. In coming to stress diagram. Stress diagram, what happens here? The neutral axis, that means lies only where the point actual depth of neutral axis lies. Okay, actual depth lies at that line only, the neutral axis will be lying. That means the compression and tension will be equal to 0 at that point. And the critical depth of neutral axis lies below some other lies below the actual depth of neutral axis. So with the help of critical depth of neutral axis, we cannot say that compression and tension will be equal to 0 here. Only with the help of actual depth of neutral axis only we can say that compression and tensile forces will be 0. So here the stress diagram became like this. Okay, it is divided into two triangles. One is a small triangle and other is the bigger triangle. In smaller triangle, if you see, at the center of gravity there is an average compressive force that is existing here in extreme fiber of the concrete. That is the what? That is the maximum compression force. Okay, maximum compression force or maximum compressive stress we can say. In similarly, in bottommost fiber of the concrete, this is the maximum tensile stress. Okay, and if you want to find out the average compressive force, why we should find an average compressive force, we are gonna see now. So for now you can say that this is the average compressive force. It lies at the distance at the depth of 1/3 from the base of the triangle. Okay, you all know what is the center of gravity, where center of gravity lies for various kinds of sections like circle, triangle and rectangle. Similarly, here it is a rectangle, so from the base it will lie at the depth of 1/3 of the height. So the remaining portion from the center of gravity of the reinforcement, to the average compressive force, the remaining depth is known as lever arm. Okay, if you want to find out the moment of resistance for compression only, then what is the formula? Compressive force into lever arm. Okay, moment of resistance for compression is equal to compressive force into lever arm. This is the formula for moment of resistance, moment carrying capacity, or you can say. Okay, and compressive force, so what is for compressive force? What is the formula? For force or for load, the formula is stress into area. That is the formula. You all know that stress will be equal to load upon area. That means load will be equal to stress into area. Similarly, here also compressive force is equal to average stress into area under stress. So into lever arm. Okay. So first of all, average stress. What is average stress here means? Okay, average stress means here C, not C, but the average stress means the maximum plus minimum by 2. That means that gives us the average stress actually. Here the maximum stress that is acting in the compression zone is CA, and the minimum stress that is acting here is 0. That minimum stress where it is acting the depth of neutral axis but in depth of neutral axis, but at neutral axis, what is the compressive stress at that point? It will be equal to 0. So CA plus 0 by 2, it becomes the average stress. And the area, what is the area formula? B into XA. Okay, it is B and it is XA. B into XA. This is the formula. So B into XA into CA plus 0 by 2 into the lever arm. Lever arm means I have already told you the compressive force, the resultant compressive force that is acting in the compression zone to the center of gravity of the reinforcement. Okay, so don't confuse here between the average stress and the resultant force. Resultant force is another thing and average stress is the another thing. Average stress means maximum plus minimum by 2. Resultant force means it is the center of gravity of any particular zone. Next, coming to moment of resistance of tension. Moment of resistance for tension. So here we have seen about the moment of resistance for compression. Now the moment of resistance of tension. So for tension, same tension force into lever arm. And for tension force, same formula, average stress into area under stress. But the tension zone should be considered. There we have seen in the compression zone. Now we are going to see in tension zone. So see average stress. Average stress means, so first of all, stresses are given sigma st by m. Average stress means maximum plus minimum by 2. Minimum here, what? Minimum here is 0 only. So sigma st by m plus 0 by 2 means, okay, sigma st by m into the area under stress. Area under stress. What is the area under stress here? M into AST. That means if we remove these reinforcement bars, what will be the equivalent area of concrete? M into AST only. So that will be subjecting to the stresses. This portion only is subjecting to stresses. That's why this portion is only considered for calculating the area. For calculating the area, what is the formula? So if we remove this circular portion, then it becomes as a rectangular portion. So what happens means, we all know the modular ratio in terms of area. What is it? M is equal to AC by AST. Then if you want to find out the AC, then it will become AC is equal to M into AST. So that is the area under stress. And coming to lever arm, same as in the compression zone, that is D minus XA by 3. It does not change, whether it might be tension, whether it might be compression. So same formula. Now coming to balanced section. Balanced section, moment of resistance for compression is equal to moment of resistance for tension. Okay. Moment of resistance for compression will be equal to compressive force into lever arm. Here what happens means that only one neutral axis will lie. That means actual depth of neutral axis and critical depth of neutral axis will lie on the same line. So that's why other lines will not be considered here. Here no green line, no red lines will be seen. So only one single line is seen here, that is the neutral axis. So in this neutral axis only, both critical depth of also there and actual depth is also there. So coming to stress diagram, it will be the stress diagram will be like this. Okay, it will be linear, and it is the maximum compressive stress and it is the maximum tensile stress. And from the resultant compressive force to the center of gravity of the reinforcement, it is the lever arm, same as the above mentioned. So if you want to find out the moment of resistance for compression, then average stress into area under stress, same formula. So B into XC, this is what area under stress actually, and this is average stress actually. This is the maximum compressive stress and this is the minimum, that is 0 by 2 into D minus XC by 3. same as mentioned above. So sigma, moment of resistance for tension also same, sigma st by m into mast into d minus xc by 3. Coming to over reinforced section, in over reinforced section, what happens means that actual depth of neutral axis lies below the critical depth of neutral axis. So this is the green line which indicates the actual depth of neutral axis lies below the blue line, that which is the critical depth of neutral axis. Blue line means here critical depth of neutral axis. Okay, so the actual depth of neutral axis is denoted by xc, and the critical depth is denoted by xc, and actual depth is denoted by xa. So maximum compressive stress sigma cbc and maximum tensile stress, that is t by m, actually t by m. Okay, here you can see that stresses have become minimum. That means as much as the stresses in compression zone, there are not as much as stresses in tension zone, if you can observe this. Why means here over reinforcement is given. Once the over reinforcement is given, what happens, the over reinforced section, once the over reinforcement is given, all the stresses will be carried, maximum stresses will be carried out by that over reinforced part, that is the steel will be carrying out the maximum stresses. So once the steel bars are more there, they will be distributing that externally coming load. So that's why their internal resistance will be minimizing. అంటే ఒకసారి ఏమైనా ఎక్స్టర్నల్ లోడ్ వచ్చింది అనుకోండి, ఎప్పుడైతే అక్కడ రెయిన్ఫోర్స్మెంట్ బార్స్ అనేవి ఓవర్గా ఉంటాయో, అంటే ఎక్కువగా ఉంటాయి, అప్పుడు ఏమవుతుంది, స్ట్రెసెస్ అనే లోడ్స్ అనేది డిస్ట్రిబ్యూట్ చేసేసి స్ట్రెసెస్ అనేది వెన్ కంపేర్ టు బ్యాలెన్స్డ్ సెక్షన్ తక్కువగానే ఎగ్జర్ట్ చేస్తాయి స్ట్రెసెస్. సో అందుకనే టెన్షన్ జోన్లో మీరు చూసినట్టయితే ఇక్కడ లెంగ్త్ అనేది మినిమైజ్ అయిపోయి ఉంటుంది, బట్ ఇన్ కంప్రెషన్ జోన్ లెంగ్త్ అనేది ఎక్కువైపోయింది. దాని యొక్క విడ్త్ ఆఫ్ స్ట్రెస్ అనేది ఎక్కువగా మనకు కనిపిస్తుంది ఈ స్ట్రెస్ డయాగ్రామ్లో. ఓకే, నౌ క్యాల్కులేటింగ్ మొమెంట్ ఆఫ్ ఏరియా ఆఫ్ కంప్రెషన్, సేమ్ b into xa into sigma cbc plus 0/2 into d minus xa by 3. Okay, moment of resistance for tension for over reinforced section is, as per IS code recommendation, the moment of resistance never be calculated from tension side in a case of over reinforced section. Over reinforced section కేసులో మనం ఎప్పుడు ఏంటంటే moment of resistance for tension calculate చేయమన్నమాట. ఎందుకంటే tension will be carrying out by what? Tension will be carrying out by steel only. Okay, because steel is a ductile material, so the moment of resistance will be so minimum. That's why it is moment of resistance for tension is neglected. As in the over reinforced section, the steel is under stress and the failure occurs due to the concrete only. So concrete lo వచ్చే failure ni ఎటువంటి type of failure అంటారు, brittle failure అని చెప్పేసి అంటారు, which makes it hard to determine the actual under stress condition of steel. అండర్ స్ట్రెస్ కండిషన్ని మనం డిటర్మైన్ చేయడానికి ఏమైపోతుంది, ఓవర్ ఇన్ఫోర్స్డ్ సెక్షన్లో మనకు హార్డ్ అయిపోతుంది, అంటే చాలా కష్టం అయిపోతుంది. సో ఇప్పుడు ఒక పాయింట్ చెప్తాను, వినండి కేర్ఫుల్గా. సో ఒకటి వచ్చేసి అండర్ ఇన్ఫోర్స్డ్ సెక్షన్, ఓకేనా, ఒకటి వచ్చేసి బ్యాలెన్స్డ్ సెక్షన్, ఒకటి వచ్చేసి ఓవర్ ఇన్ఫోర్స్డ్ సెక్షన్. ఈ 3 types ఆఫ్ సెక్షన్స్ చెప్పాను మీకు. సో అండర్ ఇన్ఫోర్స్డ్ సెక్షన్లో ఏమవుతుందంటే యాక్చువల్ డెప్త్ ఆఫ్ న్యూట్రల్ యాక్సెస్ క్రిటికల్ డెప్త్ ఆఫ్ న్యూట్రల్ యాక్సెస్ కంటే తక్కువగానే ఉంటుంది, ఇది మీకు చెప్పిన పాయింటే. బట్ పాయింట్ ఏంటంటే దీంట్లో స్టీల్ తక్కువగా మనం ఇంక్లూడ్ చేస్తాం అనమాట, వెన్ కంపేర్ టు బ్యాలెన్స్డ్ సెక్షన్ ఆర్ వెన్ కంపేర్ టు ఓవర్ ఎన్ఫోర్స్ సెక్షన్. మనం ఏంటంటే దీంట్లో స్టీల్ అనేది తక్కువగా ప్లేస్ చేస్తాము ఇటువంటి టైప్ ఆఫ్ బీమ్లో కానీ లేకపోతే స్ట్రక్చర్లో కానీ. సో దానివల్ల ఏమవుతుందంటే స్టీల్ ఈజ్ వాట్ టైప్ ఆఫ్ మెటీరియల్, డక్టైల్ మెటీరియల్. ఎప్పుడైతే దాంట్లో బెండింగ్ మూమెంట్ ఎక్సెస్గా వచ్చి లేకపోతే ఏమైనా ఫెయిల్యూర్ అనేది వచ్చింది అనుకోండి, ఆ ఫెయిల్యూర్ ఫస్ట్ కాంక్రీట్కి వెళ్ళాలా లేకపోతే స్టీల్కి వెళ్ళాలా, ఇది ఏం డిసైడ్ చేస్తుందంటే టైప్ ఆఫ్ రెయిన్ఫోర్స్డ్ సెక్షన్ డిసైడ్ చేస్తుంది. ఓకేనా, ఒకవేళ స్టీల్ తక్కువ ఇచ్చామనుకోండి, కాంక్రీట్ అనేది ఆ లోడ్ని ఎక్కువగా తీసుకుంటుంది. సో దాంట్లో స్ట్రెసెస్ డెవలప్ అయిపోయి అప్పుడు అది ఫస్ట్ కాంక్రీట్ ఫెయిల్యూర్కి సబ్జెక్ట్ అవుతుంది. ఓకేనా, ఒకవేళ ఎక్కువ ఉంటే స్టీల్ ఎక్కువ ఉంటే, ఒకవేళ తక్కువ ఉందనుకోండి అప్పుడు ఫస్ట్ ఫెయిల్యూర్ వచ్చేది స్టీల్లోనే. అంటే ఆబ్వియస్లీ ఏది తక్కువగా ఉంటే దేని అమౌంట్ అయితే తక్కువగా ఉంటుందో అదే ఫస్ట్ ఆఫ్ ఆల్ ఫెయిల్యూర్కి సబ్జెక్ట్ అయ్యే అవకాశం ఉంటుంది. ఇది ఒక ఆబ్వియస్ థింగే, అందరూ అంటే లాజిక్గా ఆలోచించేదే. సో ఎప్పుడైతే స్టీల్లో ఫస్ట్ ఫెయిల్యూర్ వస్తుందో, స్టీల్ ఈజ్ వాట్ టైప్ ఆఫ్ మెటీరియల్? డక్టైల్ మెటీరియల్. సో ఇట్ ఎలాంగేట్స్ ఆర్ ఇట్ టెంపరర్లీ డిఫార్మ్స్ బిఫోర్ ద పర్మనెంట్ డిఫార్మేషన్. అర్థమవుతుంది కదా? సో ఆ టెంపరీ డిఫార్మేషన్ అనేది మనకి ఏంటంటే క్రాక్ కానీ, లేకపోతే ఎలాంగేట్ అవ్వడం కానీ, లేకపోతే బెండ్ అవ్వడం కానీ మనకు చూపించి దాని తర్వాత ఫెయిల్ అయ్యిద్ది. ఓకేనా? అంతలోపు మనం ఏం చేయొచ్చు, ఆ పర్టికులర్ బిల్డింగ్ నుంచి అయినా కానీ ఆ పర్టికులర్ స్ట్రక్చర్లో మనం ఉంటే బయటికి వెళ్ళిపోవచ్చు. అదే ఒకవేళ రెయిన్ఫోర్స్మెంట్ అనేది ఎక్కువగా ఇచ్చేసాం అనుకోండి, అప్పుడు ఇప్పుడు లోడ్ వల్ల ఒకవేళ ఫెయిల్యూర్ వస్తే దేంట్లో వస్తుంది? ఆబ్వియస్లీ కాంక్రీట్లో వస్తుంది. ఎందుకంటే కాంక్రీట్ తక్కువగా ఉంది అండ్ స్టీల్ అనేది దాంట్లో ఎక్కువగా ఉంది. సో దాన్ని మనం ఓవర్ రెయిన్ఫోర్స్డ్ అని చెప్పేసి అన్నాం. సో కాంక్రీట్ ఏంది? బ్రిటిల్ టైప్ ఆఫ్ మెటీరియల్. బ్రిటిల్ మెటీరియల్కి ఎగ్జాంపుల్ ఏంది? చాక్ పీస్. ఇప్పుడు వన్స్ మీరు చాక్ పీస్ బ్రేక్ అంటే దానిపైన లోడ్ అప్లై చేశారనుకోండి, దాన్ని బ్రేక్ చేయాలని ట్రై చేస్తారు. సో ఏమైపోతుంది? దాంట్లో ఎటువంటి టెంపరీ డిఫార్మేషన్స్ అనేది ఉండదు. అది బెండ్ అవ్వడం కానీ, లేకపోతే ఎలాంగేట్ అవ్వడం కానీ అది ఏమీ చేయదనమాట. సో డైరెక్ట్గా ఏమవుతుంది? ఫెయిల్ అయిపోతుంది, లేకపోతే అదే పొజిషన్లో ఉంటుంది. ఓకేనా? సో అటువంటి టైప్ ఆఫ్ మెటీరియల్, అటువంటి టైప్ ఆఫ్ ఫెయిల్యూర్ అంటే మనకి కన్వీనియంట్గా ఉంటుందా ఏదైనా కానీ? సో అటువంటి టైప్ ఆఫ్ ఫెయిల్యూర్ అనేది మన బిల్డింగ్లోకి రాకూడదు. బ్రిటిల్ ఫెయిల్యూర్ అనేది రాకూడదు. సో అండర్ రెయిన్ఫోర్స్డ్ సెక్షన్ వచ్చేసి మనకు డక్టైల్ ఫెయిల్యూర్ ఇస్తుంది, అండ్ ఓవర్ రెయిన్ఫోర్స్డ్ సెక్షన్ అనేది మనకు బ్రిటిల్ ఫెయిల్యూర్ని ఇస్తుంది. బ్యాలెన్స్డ్ సెక్షన్ కూడా మనకు అంత కన్వీనియంట్ కాదు. ఎందుకంటే బోత్ కాంక్రీట్ అండ్ స్టీల్లో వచ్చినా కానీ అది వన్ టైప్ ఆఫ్ బ్రిటిల్ ఫెయిల్యూర్గానే ఉంటుంది. ఎందుకంటే కాంక్రీట్ కూడా దాని యొక్క మ్యాక్సిమం పర్మిసిబుల్ లిమిట్కి రీచ్ అయిపోతుంది కదా, సైమల్టేనియస్ టు స్టీల్ అది కూడా దాని యొక్క మ్యాక్సిమం లిమిట్కి రీచ్ అయిపోతుంది. అప్పుడు ఏమవుతుంది? స్టీల్ ఒకవేళ డక్టైల్ మెటీరియల్ అయినా కానీ అక్కడ కాంక్రీట్లో కూడా ఫెయిల్యూర్ వచ్చేసి ఉంటుంది. సో దానివల్ల అది కూడా ఏమవుతుంది? సడన్ కొలాప్స్ అనేది జరుగుతుంది ఏదైనా స్ట్రక్చర్లో. సో అందుకని బ్యాలెన్స్డ్ సెక్షన్ కూడా మనకు అంత ఎకనామికల్ కాదు. స్టీల్ అనేది కాంక్రీట్ కంటే కాస్ట్లీ మెటీరియల్ కదా. మళ్ళీ స్టీల్ ఫస్ట్ ఆఫ్ ఆల్ అండర్ ఇన్ఫోర్స్డ్ సెక్షన్ అనేది మనకు సేఫ్టీని ఇస్తుంది. ఇది ఫస్ట్ ఫ్యాక్టర్. సెకండ్ ఏంటంటే స్టీల్ అనేది కాంక్రీట్ కంటే కాస్ట్లీ మెటీరియల్. సో దానివల్ల ఏమవుతుంది? మనకు ఎకనామికల్ కూడా అండర్ ఇన్ఫోర్స్డ్ సెక్షన్ అంటేనే స్టీల్ని తక్కువగా యూస్ చేయడము. సో దానివల్ల మనకి ఏమవుతుందంటే ఎకనామికల్ కూడా పడుతుంది ఈ అండర్ ఇన్ఫోర్స్డ్ సెక్షన్ అనేది. ఓకే గైస్, సో ఈ క్లాస్లో ఇంతవరకు I think it is sufficient for you. So we will meet in the next class with the upcoming videos. Hope you like this class and enjoyed watching. And if you have any queries regarding this topic, you can mail me. Na mail telusu kada. So this is my mail. Okay. If you have any queries, you can mail me. And now, thanks for watching. Thank you guys. Have a nice day.